through some examples of maxima and minima. So our first example is f of xy equals negative 2x squared minus y squared plus 3y. So first we're going to find the critical points. So we've got to find the x derivative, which is negative 4x, and our y derivative, which is negative 2y plus 3. Since our gradient equals 0, each of these partial derivatives is going to equal 0. So we have negative 4x equals 0 and negative 2y plus 3 equals 0. So we're going to have a critical point where x equals 0 and y equals 3 halves. So this is our critical point. Zero and 3 halves. So now we're going to find our d. So we need f of x, the second derivative with respect to x, which is going to be negative 4. Second derivative with respect to y, which is negative 2. And the mixed partial derivative, which is going to be 0 in this case. So now we define d as so we're going to have negative 4 times negative 2 minus 0 squared. So d is going to be 8. So d is greater than 0. And check there, f of x is less than 0. So if you go back to our list here, you have d greater than 0, f of x less than 0. So we have local maximum at 0 and 3 halves. So do one more example. We have f xy equals x times 1 minus x plus y, and we can rewrite this as x minus x squared plus xy. So let's find the partial derivatives. It's going to be 1 minus 2x plus y, and this is going to be x. So we set these both equal to 0. So we know x has to equal 0. So let's plug that in here. So we know this is going to 0. So we have 1 plus y equals 0. So y must equal negative 1. So our critical point is 0, negative 1. So now we find our second derivative, which is negative 2. 0, 0, and f of xy is going to be 1, so we have d that's going to be negative 2 times 0 minus 1 squared, which is negative 2 minus 1. This is going to be, this is going to be 0. So d is less than 0, because we have d equals negative 1, so this is this case, so it's the saddle point at 0, negative 1.